Assalamualaikum and greetings everyone. We are group number 6 and we will be presenting our project entitled Diesel Generator. My name is Amira Nurkitina bin Zain and my metric number is B0421100059. Next.
Okay, my name is Ifan Fauzi bin Afindi and my number metric is B0421100218. Next.
Okay, my name is Muhammad Danish bin Abdul Jabbar and my metric number B0421100089. Next.
My name is Sagir Sangal. My matrix number is B0421100209.
For the introduction of our project, this is the portable diesel generator. The objective of our project is to improve the reliability and performance of diesel generator, to identify component failures and manufacturing weaknesses, and to propose and validate design improvements. Our target users is domestics, small businesses, construction, and agriculture. So the issues here is that the increased component failure impacting market competitiveness. Moving on to the manufacturing processes, there are 7 processes. The first one is frame fabrication, which is this process begins with building a steel tube frame where it is cut, welded, and powder coated for corrosion resistance and protection of internal components. The second one is engine assembly, where a 4-stroke compression ignition engine is used. Key parts like crankshaft, pistons, valves, and camshaft are assembled with high precision. The third one is air intake and exhaust setup. The air filter and intake system are added to ensure clean air enters the combustion chamber, and the muffler is connected to safely release exhaust gases and reduce noise. The fourth one is alternator installation. A single-phase alternator is mounted and aligned with the engine's output shaft. It is then tested for proper voltage and frequency output. The fifth one is ignition and control installation, where components like the spark plug, ignition coil, and flywheel magneto are calibrated to match the piston movement for smooth operation. The sixth one is cooling and fuel system setup, which an air cooling system using fins and a flywheel mounted fan helps manage engine heat. And the fuel tank is positioned for gravity-fed fuel delivery to the carburetor. And the last one is the final testing, where once assembled, the oil and fuel are added, and the engine is then started and tested to ensure everything operates as expected. I will pass this slide to Danish.
So next, I will explain about assembly and quality assurance. Assembly and quality assurance is the stage where the design transforms into the dependable functionality. Every component we have carefully selected, now we come together and precision become paramount. We begin by mounting the engine and alternator onto the frame using shock absorbing mount. This is just a mechanical stability. It plays a critical role in reducing operation vibration, extending the lifespan of surrounding component, and enhancing user comfort during prolonged use. Next, each fastener is taught to a specific value. We use a calibrate tool and apply thread locking compound to prevent loosening caused by engine oscillate or thermal expansion. This attention to fastening integrity is key to minimize the risk of mechanical failure over time. The third one is the electrical subsystem follow. All wiring is routed and secure to prevent cafing, and every connecting undergoes connecting and resistance check to ensure there are no weak links. Consistency here is vital, especially under real-world conditions where temperature, humidity, and handling might vary. We also integrate a suite of sensors such as full level temperature, exhaust condition, and voltage regulation. Each sensor is calibrated and strategically place to provide real-time feedback during operation, enabling proactive maintenance and safer usage. Finally, the generator goes through a battery of automatic tests. These include power output verification, ensuring that voltage and frequency fall within safe tolerance, noise level assessment to comply with user comfort expectation, vibration analysis to catch imbalance, and humidity resistance tests to simulate tropical and high moisture environment. Only when a unit passes all these tests without deviation, those in an hour critic seal. In short, display is not just about putting parts together. It's about engineering trust into every single unit before it leaves the floor. Next, I will pass to the Ifan Fauzi.
Okay, for my part, it is manufacturing issue. There are 10 components in diesel generator that causing issue during manufacturing. Okay, firstly, there is crankshaft. This part converts piston motion into rotational force. If it's weakened by stress or poor heat treatment, it may crack and causing complete engine failure due to the loss of mechanical motion. Next is piston. Piston, when operating under high pressure and temperature, piston can suffer from wear or cracks. When damaged, they reduce compression, leading to lower power and poor fuel efficiency. Third is cylinder block. This structure houses the cylinder. Thermal stress or casting flaws can cause cracks, often leading to coolant leaks, overheating, and eventually engine breakdown. Fourth is alternator coil. This coil generates electricity. If its insulation fails or the coil overheats, it can stop charging the battery and can disabling the diesel generator electrical system. The fifth is fuel injector. Fuel injectors spray fuel in fine mist form. Dirt or deposits can block them, disrupting fuel delivery and causing misfires, rough idling, or emission issue. Okay, next is control panel. Control panel is the main interface for operating the diesel generator. If it develops issue like software bug, short circuits, or display error, user cannot adjust setting, monitor performance, or start the generator easily. Next is radiator. The radiator helps manage engine temperature. If it becomes clogged or leaks coolant, the generator might overheat, which can lead to shutdown or engine damage. Next is voltage regulator. This part keeps the voltage stable. Faults here may cause the generator to send too much or too little power, potentially damaging device connected to it. Next is starter motor. The engine will not start without this component. Problems like worn out contacts or weak battery connection can stop the generator from switching on when needed. And lastly, wiring harness. This is the electrical lifeline of the generator. Damaged wires or loose connections can cause system failures, erratic behavior, or complete loss of function.
Okay, for the component reliability analysis, this is the data generated for the 10 critical components of the diesel generator. As we know, This is the reliability of each of the following components. And for this, it is under series configuration. As we can see from the reliability block diagram for the series configuration, we can know that it has a low total reliability of 0.31. If one fails, the other fails. And now here's the upgraded version where we use the series configuration. Next slide. Okay, so for this, it's the hybrid configuration where it has the control panel and the fuel injector has an increasing reliability value. And if we go to the reliability block diagram, and now this is the hybrid reliability block diagram. So as we can know, the parallel redundancy has added for the fuel injector and the control panel. So if one of the fuel injector has failed, the other one can support it. And same goes to the control panel, which gives us a value of 0.45 and increase of 0.14 in reliability. For the root cause analysis, there's 4 components which is important. So for the reliability of the fuel injector is 0.83 and the identified issue is susceptible to clogging pressure loss. And the root cause summary is poor filtration and outdated design. For the control panel, the reliability is 0.85, moisture sensitivity, and unexpected resets. And root cause summary is unsealed casing, low-grade components. For wiring harness, it's 0.84, short circuit risk, and loose connection, which has a root cause summary of heat degrading insulation and loose trims. We now outpass to Christina.
All right, for the conclusion, the identified critical links that we have discussed before is the fuel injector, control panel, and wiring. So this system reliability increased through the design modifications. Monitoring confirmed early success and the long-term strategy, which is standard compliance, customer satisfaction, and market growth. That is all from our group. Thank you, everyone.
Thank you.
Thank you.
Thank you.